Hello, my dear students. Welcome back to Shlokas Academy YouTube channel. In the last session, we have discussed discovery of fundamental particles. That means discovery of electron, proton, and as well as neutron. All three fundamental particles were discovered, and how they were discovered, all these things we have already discussed in the previous videos. And in this video, how these fundamental particles are arranged within the atom. That means the model which can explain the complete arrangement of all fundamental particles inside the atom is called as atomic model. And in this video, we are going to discuss about atomic models. Atomic models. So here we have three atomic models or four atomic models completely. One by one, we will discuss. What is the atomic model definition? It is a model which represents the complete arrangement of all fundamental particles present inside the atom. Means within the atom, how these fundamental particles, proton, electron, and neutron, are present inside the atom. To know this arrangement, the scientists have started to establish atomic models. The first atomic model established by the J.J. Thompson, which is called as J.J. Thompson atomic model, which is called as J.J. Thompson atomic model. And the second atomic model that was established by Rutherford, which is called as Rutherford atomic model. And third one, Bohr's atomic model. And the last, wave mechanical model. And in this video, we are going to discuss about Thompson's atomic model and as well as Rutherford's atomic model. And the rest of the two in next video. Okay. So let us move on to the first atomic model, that is Thompson's atomic model. What is Thompson's atomic model and what are the postulates given by Thompson's? What was the suggestion given by Thompson and why it was discarded? Means what was the drawback of this Thompson atomic model? That we will discuss. Right. First, let me discuss about Thompson's atomic model. What is Thompson's atomic model? So according to Thompson's atomic model, he suggested that if I consider this one, all of you look at here, this one, this is atom. This total is considered as atom, which is a rigid sphere. And this red color is positive charge. Positive charge means the positive charge present in the atom has distributed uniformly throughout this sphere. And the electrons, these are negative charges, these are electrons. And electrons are embedded in such a way that to neutralize the positive charge of the atom. It is just like watermelon. It is just like watermelon. If you consider watermelon, if you cut it two equal halves, you can find the red color in the watermelon. That red color is positive charge. And if you can also find the seeds which are black in color, they are embedded throughout that watermelon in such a way that to neutralize this positive charge. So that was the assumption given by Thompson's atomic model. But it was discarded. Why? Because it was unable to explain the famous experiment, Rutherford gold foil experiment. And it was unable to explain the stability of the atom. So that is why this atomic model was discarded. What was the assumptions given by Thompson's atomic model? Once again, we will review the Thompson's atomic model important postulates and what were the merits and what were the demerits, all these things. If I take Thompson's atomic model here, right, the first one, Thompson was the first to propose a detailed model of the atom. He was the first scientist who discussed about arrangement of subatomic particles within the atom. Right, and he proposed that an atom consists of uniform sphere of positive charge. Already I have told that a positive charge is uniformly distributed throughout the sphere. Charge in which the electrons are present at some places. So how the electrons are present? Like seeds of the watermelon. That is the reason this is also called as watermelon model of atom. Right. This model of atom is also known as plum pudding model or watermelon model. So these are the 2 points that was given by J.J. Thompson. Right. Next, what are the drawbacks? Drawbacks of Thompson's atomic model. Right. An important drawback of this model is that the mass of the atom is considered to be evenly spread over the atom. That means Thompson has told that the positive charge have distributed throughout the sphere uniformly. That means all massive particles are also distributed throughout the sphere uniformly. That was wrong. And it is a static model. Means in this model, it did not say whether the electrons are moving or not. It does not reflect the movement of the electron. That is why it was the static model. So that was also one of the drawback. And the most important drawback, it does not explain the very famous Rutherford gold foil experiment. It did not give the explanation for Rutherford gold foil experiment. Because of these reasons, the Thomson's atomic model was discarded. So after that, the scientist Ernst Rutherford has come with another model which is called as Rutherford atomic model, right? So what is that Rutherford atomic model? And first let me explain what is Rutherford atomic model, right? And how we can explain what is the experimental setup. Rutherford atomic model, which is also called as Rutherford gold foil experiment, which is also called as Rutherford gold foil experiment or Rutherford alpha scattering experiment, right? Which is also called as Rutherford scattering experiment. Whatever it may be, I am calling it as Rutherford gold foil experiment or Rutherford atomic model, right? Now here, it is very important for competitive examinations like JEE Mains and JEE Advanced and JEE NEET also, right? So here we are going to discuss about first experimental setup. Means any experiment you want to discuss, first we should discuss what is experimental setup. Then what is experiment? Means during the experiment what you have observed, observations. And after that conclusions. Then finally result. So here also first we are going to discuss about Rutherford experimental setup, right? So let me explain what is the experimental setup that was set up by the Rutherford. First, so here this is a radioactive source. Radioactive source means it can give the alpha particles. It can give the alpha particle. First of all, right here I want to discuss what is alpha particle. So generally when you take helium, right, the helium I can represent like this. Here the 2 is the atomic number and the 4 is the mass number. So helium is a neutral atom because in the helium we have 2 electrons and we have 2 protons. In the helium we have 2 electrons and we have 2 protons. Means 2 negative charges, 2 positive charges. That is the reason the helium is existing as neutral. And from this I am removing 1 electron. So there were 2 negative charges and 2 positive charges. If I remove 1 negative charge from that, so what would be the charge on the helium? I may get a +1 charge, right? And I can say that it is ionized helium ion. It get ionized. Initially it was neutral and it ionized to +1 charge. Now here 1 more electron I am removing. 1 more electron I am removing. Then what could be the charge on this helium? It should be +2, right? So I can say that it is doubly ionized. 2 times it get ionized, right? Doubly ionized, right? Helium atom. Doubly ionized helium, which is also called as alpha particle, right? Now, do you all understand what is alpha particle? Alpha particle is nothing but A doubly ionized helium atom is called alpha particle. And if I ask you what could be the charge on the alpha particle, means it is positive charge. And if I ask you what is the magnitude, it is +2. Magnitude is 2 and its a sign is plus. So positive charge. Simply I can say that here if I take any radioactive substance that can give alpha particles as stream of light, right? So whatever the alpha particles that are coming out from this source, right, they can spread throughout the room. But I want to make into a beam of alpha particle. For that, I should use one slit. Slit means it can make a full stream of alpha particles into a beam of alpha particles. Now, these alpha particles are allowed to passing through a thin gold foil. Gold foil means it is just like chocolate wrapper. Whenever you purchase Kit Kat chocolate, you can find one silver foil, a silver cover wrapped wrapped on the chocolate. The silver cover is called silver foil or aluminium foil. Means that is very thin. In the similar way, instead of that, we will take gold foil. Gold foil, right? And the alpha particles are passing through this gold foil. And here, beyond the gold foil, I have kept one zinc sulfide screen. What is the role of this zinc sulfide screen? Means if any charged particle hits this zinc sulfide screen, it will give one spark. So that we will come to know that some charged particles are touching the zinc sulfide screen and we can locate where it is touching. So this is the experimental setup. And whatever the observation experimental setup, you can neatly draw the experimental setup here. So draw into your notes and write the definition of the alpha particle here. What is the definition of the alpha particle? A doubly ionized helium particle is called as alpha particle. And what is the charge on alpha particle? Means it is a positive, and if you go for magnitude, it is +2 charge, right? And next we should go for this diagram. You have to draw it. Then observations. What are the observations that we will discuss? What were the observations observed by the scientist Rutherford? Means after the experiment compulsory we should go for observations or not. So they made means Rutherford and his team were made 3 major observations. The first observation I am discussing here, right? Most of the alpha particles, that means almost 99.9% alpha particles are passing through the gold foil without any deflection. Means just the nature of alpha particles, they travel in straight line direction. Even though they are passing through the gold foil, they are not changing their direction. 99.9% of the alpha particles are passing through the gold foil without any deflection. This was the first observation. And the second observation, very few alpha particles, means very less. Few alpha particles are deflected through small angle of deflection like this. Means actually they're supposed to travel in straight line direction, but they are changing their path. They get deflected through small angles. The angle of deflection is very small. This is angle of deflection, very small, right? And third observation, very few alpha particles, very few. For example, if you take 20,000 alpha particle, out of 20,000, only one alpha particle, it come back on its own path. Means it returns back on its own path. Means here, what is the angle of deflection here? It should be 180 degrees. 180 degrees. That means what were the 3 observations made by the Rutherford? The first observation, most of the alpha particles, that means 99.9% of the alpha particles passing through the gold foil without any deflection. And the second one, few alpha particles, they get deflected through small angle of deflection. And third observation, very few alpha particles, about 1 in 20,000 alpha particles are getting back on their own path. That means they have deflected through an angle of 180 degrees. So these are the three observations. Once again, I will review on the observations. Three observations. The first observation, most of the alpha particles, one by one, I'll discuss. Most of the alpha particles, already I said 99.9%, right, went straight without any deflection. They went straight without any deflection. A few of them, means very few of them, got deflected through small angles. Second observation. Third observation, a very few alpha particles, that means about 1 in 20,000, come back in their direction from which they have come. That means their original path, that is, they got deflected through an angle of 180 degrees. These are the three observations made by the Rutherford. Now, by using these observations, we should discuss conclusion. What were the conclusions? Once again, I will discuss these observations with conclusions. What was the first observation made by them? The first observation, most of the alpha particles are passing through the gold foil. This is one atom of the gold atom. I'm taking, this is one of the atom which is belongs to gold, right? Are passing through the, I'm taking, most of the alpha particles are passing through this gold atom without any deviation, means they are passing straightly. This is first category, means from first observation I have drawn this one. Second observation, few alpha particles, they get deflected. They get deflected from their path like this. They get deflected through small angles, not that much, right? And very, if I take some more alpha particles, they can deflect in this manner also, right? And if I take here, they can take in this manner also. And very few, this category is B, means second observation. And the third observation, very few, that is out of 20,000 one alpha particle, it is getting back on its own path. So this is C category. This is from observation 1. That means most of the alpha particles are passing through the gold foil without any deflection. This is from second observation, that is few of them, right, passing through the alpha particle, passing through the gold foil with a small angle of deflection. This is very small angle of deflection. And very few, that is out of 20,000, only one alpha particle is getting back on its original path. That means it is making an angle of 180 degrees. So these are the three observations. From these three observations, they made three conclusions. What are the conclusions? I will discuss here. From the first observations, they have decided that most of the space in the atom is empty. Most of the space in the atom is empty, means there is no massive particle or there is no positively charged particle. Because, for example, if you find any positive charged particle, if you find any positive charged particle in this area, alpha particles must be repelled. Because what is the charge on the alpha particle? Positive, right? And if you find any positive charge in this space, so obviously the alpha particles get repelled because of this positive charge, and they must change their deflection or not, but they are not doing so. That is why, so I can say that most of the atom, most of the space in the atom is empty. That was the first conclusion. Second and third, from the second and third observation, right? From the second and third observation, they have defined the term nucleus. What is the term nucleus? Means there is a smallest region in the atom present exactly at the center of the atom, where all positively charged and massive particles are concentrated in it. This is the smallest region in the atom present exactly at the center of the atom, right? And in this region, all positively charged particle and massive particles are concentrated. Because of this smallest region, the alpha particles which are coming closer towards this nucleus because of this positive charge and positive charge present on the alpha particle, they get repelled and they change their direction and they got deviated. And out of 20,000 which is getting back on its original path, that is mainly due to it is directly coming straightly towards the nucleus. So compared to other alpha particles, here the alpha particle will experience a maximum repulsion. Hence, it will get back on its original path. That was a 2 and 3 observations. They have defined the nucleus and they concluded that because of the nucleus, as the alpha particles moving closer to this nucleus got deflected through small angles. And the third observation, the alpha particle which is straightly moving towards the nucleus, which is about to hit the nucleus, is experiencing more repulsions and it get back on its original path. That means it suffered from an angle of 180 degrees deflection. So these are the three conclusions. Once again, I will recall. Here you can see it in this diagram. See here. So the alpha particle plus 2 charge, 2 positive charges they have given, which is coming closer to the nucleus. Here it is coming towards the nucleus, right? So that here what happened? What is the charge on this nucleus? Positive charge. Because of the positive charge, positive, this is also positive and it is also positive. They get repelled and they change their deflection. Actually, it is supposed to go straight line, but it changed its direction because of repulsion. And this is away from, this alpha particle you can observe away from the nucleus. That is why no repulsion, no deflection. And it is somewhat closer to the nucleus. Hence, because of repulsions with this nucleus, it get deflected. And here, the one which is going straightly towards the nucleus, and it get maximum repulsions and it get back on its original path. Here the angle of deflection is 180 degrees. And here these are moving away from the nucleus, hence they are moving, passing straightly. So now by using this diagram, you will come to know very clearly, right? And this is about the, what is that, observations and conclusions. Now, observations. Already we have discussed from one observation, one conclusion. First observation. Most of the alpha particles, that means almost 99.9% alpha particles, went straight without any deflection. Yes, it is true. So from this, what he concluded that most of the space in the atom is empty. Right. From the second, what was the second? The second one is a few of them got deflected through small angles. Very small angles. So from this, what they concluded that it was concluded that whole of the positive charge, means the total positive charge is concentrated and the space occupied by this positive charge is very small in the atom. That small space is called as nucleus, right? Nucleus definition. And the third one, right? Third one, they have concluded that in the third one, a very few alpha particles, about 1 in 20,000, come back in the direction from which they have come. That means, right, they returned on their original path, that is a deflection angle of 180 degrees. So this is because a very few alpha particles suffered strong deflections on even return on their path, indicating that nucleus is the rigid and alpha particles and recoil due to direct collision with the nucleus. So these are the conclusions made by the observations, made by the Rutherford from these observations, right? And after that, nucleus definition they have decided. The positively charged heavy mass which occupies only a small volume in the atom is called nucleus. So this is all about Rutherford gold foil experiment. What we have discussed? We have discussed about experiment, that is experimental setup. And after that, we have discussed observations, right? And we also discussed from these observations, conclusions they made. And the fourth, still we have to discuss results of this Rutherford atomic model. So from these results, compulsory we can expect the question for JEE, mains or advanced, and as well as for NEET also. The results are very important. Till now we have discussed about experiment, observation, conclusion, and result, right? So results are very important. Here we will have three results. First result, how to find out radius of the given atom. Second result, what is the angle of scattering, right? The second one. Third one, distance of closest approach. These three are, the third one is very important towards advanced point of view. So this is today's class, and please write the notes continuously and regularly. Watch. Thank you for watching this video, and subscribe and share with your friends. It is very helpful. Thank you.